All right, time for another draftphysics.com, debatephysics.com also, but can't get it, can't find a debater. Not possible to find somebody who can make a video response explaining how anything I'm going to say in this video is decidedly wrong. It's not like anything, but the substance of anything in the video is wrong. All right, so I'm going to play a veritasium video, another wooey pile of absolute ignorant, stupid crud, wooey religious mush, promoted as some sort of high science when it's just high wooey crap, because they can't think outside of their instructed boxes. And, they've bought a silly notion of reality. So, they replaced God with a bunch of mushy superpowers. Little tiny electrons now have all kinds of properties. They're spinning, they're polarized, they create fields, they do all kinds of crap. And it's just that crap. And you idiots fall for it, And, there's not much you can say because it's so obviously understated and underproven and underdemonstrated, and their own drawings make no sense at all. I mean, the discontinuity, they'll say it's just like, and if you really look at it, it's nothing like. And it's just so bad. So this video will probably take a while because he's going to be using a bunch of the standard bullshit arguments to set up some sort of big finish where he's going to basically say everything's just wooey woo, wooing woo woo woo. And that's it. It's just going to be this nonsense that photons can read our minds. They can go every path possible and then figure out only to go one way, but they tested all the other ways first. And it's just so goddamn ESP wooey Sasquatchian goddamn UFO wacky crap. And I'm just amazed that people accept this shit. So I made a video about electricity and basically convinced everybody that electricity doesn't travel through fucking wires, when you can watch the fucking wire melt with the electricity going through it. But oh no, there's no electricity going through the wire. I mean, it's just so goddamn stupid. All right, so yes, my task is onerous, because people won't listen. They can't watch more than one video, so they end up watching this idiot talk wooey crap, and none of it is in any way argued because the rest of the talking heads, they're all afraid to argue with each other, I think, and frankly, they're all wooey. They're all religious kooks. They all believe in this woo physics, quantum woo, qubits, woo, quantum computer, all this crap that's never going to happen because they don't understand physics at all. They can't even get energy right, as I've pointed out. They can't even figure out that an energy duality is retarded. That energy, something can't be both momentum and kinetic energy. You have to pick one, and they always pick the wrong one. All right, so is that as a premise? This will come up, the double slit, so I'm just going to point it out early, just to get it out of the way, that there's lots of ways of explaining, but they can't even be honest about something as obvious as the single slit creates a pattern. Okay, if you look at the pattern, it's almost like the double slit. The double slit has the feature of having two patterns, the little tiny pattern and then the blob pattern, the envelope pattern. They never talk about that though, and they never talk about this double maxima because water waves don't produce it. That's why they don't talk about it. Anyway, but the single slit is sitting there looking at you saying, okay, how the hell can you possibly make two waves come out of this to interfere with each other? How does the photon make two waves coming out of this single slit? So obviously that doesn't happen. It doesn't happen in water. Water does not create this pattern. All right. And the only explanation there is there's only two things that could be sources. And guess what? Their math identifies the two things. It says it right in their math. This distance, this opening distance is the distance they're using. They're basically saying, yeah, there's two sources. one source, two source. So they're basically conceding it's about the surfaces. All right, there's no way around it. Their math is perfectly describing to you exactly where the phenomenon happens, and it happens right on the surface. Okay, there's scatter happening right on the surface. Little bits of photonic material is being scattered and thrown at the wall. And there's a 50-50 chance it's back in phase or going out of phase. It's a 50-50 chance you're going in phase or out of phase. There's no other choice. There's just going in phase or going out of phase. The ones out of phase aren't going to be seen as photons. The ones in phase will be seen as photons. It's that frickin' obvious. And then when you look at the double slit, what's the main feature? Okay, this distance, if you have this distance the same size as this distance, that will give you exactly the same envelope. And what have you really changed when you bring two single slits together? What's the new thing? Oh, this distance here, this really big distance. That's the only thing that's changed. And the bigger the distance, the more possible vectors that are capable of being in phase and out of phase. So the distance basically says how many times can you create a wavelength of difference. And it is an actual number of times. There's not an infinite number of these things. There's a very specific number, and it's dictated by exactly that. How many wavelengths fit in that total distance? And that tells you how many places you can have a wavelength, a full wavelength of difference in the two lines. And it works perfectly. And if they projected this on a round surface, they'd figure out that, yeah, there's a limited amount of pattern. And guess what? The pattern really doesn't go this way. The pattern doesn't go that way. But they've never even tested for the circularity of it. You know, whether or not it's an infinite pattern in terms of space. It can't be an infinite pattern in terms of if you actually did it on a curved surface, you'd find that the nodes, the little bits, get bigger and bigger as you go towards the zero and smaller as you go through towards the center. So it's still just a number. So if there's 17 wavelengths between these 2 points, that means there's going to be 17 places where you can have a change from in phase to out of phase. So 17 on this side, 17 on that side. You figure out 35 altogether. And so it's that mechanical. And so obviously what's happening, this is just about surfaces. Surfaces are the point sources. They're driving this thing. So any photon that has part of itself go near the surface where there's a bunch of jiggling electrons. So there's electrons jiggling on the surfaces. You have a photon going through. It adds its momentum to those electrons. Those electrons jiggle in a new direction. They push on the field of energy that's surrounding everything and create a photon in this new direction, a piece of energy in the new direction. They send a bit of Morse code, so to speak. Okay, they take a energy coming in, ... and turn into ... or, you know, some other form, but they're moving into the field. As they move into the field, the little bits are hitting and reflecting, and now they're going to reflect at a higher frequency because they've encountered the electron. And obviously going the opposite way, it's doing exactly the opposite. When the electron is moving away from the field, it's obviously expanding the frequency. It's so it's so easy to understand. Once you stop doing it wrong, right is really easy to find. So as long as you get that wrong idea of woo, like it matters that where the openings are, which one went through what opening, you get rid of that opening crap and recognize there's two obstructions. The single slit is the two surface experiment. The double slit is the four surface experiment, the four source experiment. There's four sources of bits of photon being spewed by those surfaces. And again, there's a 50-50 chance on the surface, in phase, out of phase. So when all four sources hit a spot, you get a solid bright. When only two sources hit, yeah, it's not quite as bright. It's very dim. And that's the difference. And that's you can see it in the pattern. You can actually see the little missing nodes usually. There's little faint little photons there, like a quarter of the amount of photon, indicating that, yes, this is more complicated than some silly, well, it's different than some silly interference thing where we know photons can't hit photons. We know photons can't hit gravity. Well, I know they can't hit gravity. They can't hit electricity. They can't hit anything else. They can't hit a force. Forces don't interact with forces. Oh, God, I just can't believe you have to do this over and over again. All right, so let's play the crappy video. And it's just so bad. I'm just amazed that, I thought, once you give people a better view, that they'd say, shit, I get it. There's a better answer than this wooey crap. But you still just go for the woo. All right, so I might as well throw this in as a premise also. So if you understand the universe as this field of stuff, we're all surrounded by energy hitting us all the time, and it's made out of quanta. Okay, so the quantum mechanics part is right. This is about little discrete chunks of Planckness, you could even say. So part of that story is correct. But they've got it all wrong. There's nothing waving. They're little bits flying little straight line vectors. And what electrons and protons are constantly doing is this. Okay, and if they do this really quickly, you can understand that if I could move my hand at the speed of light, I would collect every single piece of light because the light can't reflect off of me because I'm going the speed of light. So if you forget the Einstein nonsense about light always reflects at the speed of light, and recognize that if something's actually moving the speed of light into stuff that's moving the speed of light, that it would have to collect it because it can't reflect it. Because it's going the speed of light. The light is going the speed of light. They go the same speed. So you'd create a big blob of light. When this hand stopped, all of the photons collected through that whole passage would fly off. Now, matter doesn't go the speed of light, so the whole point is, though, the faster the electron goes, the tighter the frequency is going to get. The more it smashes into little bits, the faster this hand goes. If those little frequencies, little bits of stuff banging into my hand, if I push into those little bits, you can understand I'm going to increase their frequency. I'm going to decrease their wavelength. I'm going to make them closer and closer together when they reflect. All right. I haven't made more energy. I've just now created a piece of energy that can give something acceleration quickly. So there's a big difference between accelerating something quickly, okay? So I could hit something, a tipping point argument. I can hit it, and then it swings back, and then I hit it again, and it swings back, and I hit it again, it swings back. Or I can hit it real fast and tip it over. And that's the argument here. The only way you can knock an electron loose is you have to hit it with enough, you have to get it to move fast, because the other electrons and the protons are trying to hold it, but they're holding it with a speed of light force. So if you move it very fast, the force doesn't get to it. There's no tension anymore because you're kicking it out so fast, it's separated from the glue essentially, and it's no longer glued. So if you can accelerate something to a high velocity quickly, you can eject it. But if you try to accelerate it slowly, the drag forces cling to it. Okay, it's stuck and you can't get it loose. And that's the simple explanation for the ultraviolet catastrophe nonsense and all of that. So all that's going to be in the video. But I just want to give you the illustration. You don't have to believe in the woo. Okay, you can believe the universe is a mechanical system like Descartes did. A religious kook, well, maybe he was. It's hard to say what he said about religion because he actually believed it, and what he said because he was afraid to be killed. So clearly he never went through the whole process of being ordained or any of that crap, so he kept as unreligious as he could. But yes, everything he wrote is layered with God crap. But you're saying, yeah, everybody had to do that or get killed. So, but anyway, The point is that, Newton and Descartes and Galileo gave you a mechanical universe, and you've thrown it all away for this wooey, silly, religious, mushy, Holy Ghost bullshit quantum magic. There's no magic. It's a mechanical universe. It's strict rules. It's always reliable. It's just absolute nonsense to talk about things poofing in and out of existence and antiparticles and all this crap. It's just crap. You don't have to believe that crap. There's better explanations if you look for them. See, this is showing charge. It's showing the creation of electrons and protons out of a simple mechanical force that only does push, reflection, and transition. Three functions, and that's it. The whole universe runs on it, but I'm not going to explain that in this video. But anyway, it works. You don't have to believe in woo magic. It's not a pull-averse, it's a push-averse. Everything bangs into things. Things move because they are forced to move. Force moves matter. And force is absorbed by matter. Matter doesn't keep moving unless it's got force pushing it. You're just so frickin' ignorant, and wrong. You're ill-informed, and you're apparently not curious enough, or you're not revolted by religion enough, because all they're selling you is religion, just wooey talk about magical properties, and you really shouldn't be buying it. Alright, so this stupid video is titled something like, "Something strange happens when you trust quantum mechanics." And it has some indication of something called an infinite slit thing is in the icon. So anyway, I had to download the video because the commercials were insufferable. And there's one in the video on top of that. But there's just all of this is just so bad. There's another one in my recommended videos here, Chapter 6, Resolving the Wave-Particle Duality of Photons. And it's all, wavy crap, of course. Resolving it as Holy Ghost, mushy, magical properties that the most elemental bits in the universe have all of these fancy functions. And somehow biology can't capture any of it. Somehow biology can't put any of it to use. All these magical stuff. Free momentum. Yeah, somehow we can't take advantage of the free momentum mechanisms. Oh, just the whole thing is so bad. I've never thought that I was like brilliant. Never really as an idea. No, I was pretty good at golf and this and that. I could say, I was pretty good at that. I was pretty good at that. Throwing rocks in a bucket. Yeah, I'm really good at that. Horseshoes, really good at it. Never really thought of myself as being smart. But I mean, you people are just making it obvious. I'm not even trying. All right, and you're failing so dismally. I mean, this lesson isn't that hard to teach. You're just belligerently stupid. So compared to the belligerently stupid, yeah, I'm fucking Einstein. Because I'm not belligerently stupid. I'm only stupid when I have to be, when I couldn't avoid it, when, I took every opportunity not to be stupid, and you take no opportunity not to be stupid. Listen to this little putz.
As a 42-year-old who's spent most of my life studying physics, I must admit...
So I don't know, did you just regurgitate physics? Did you just sit there and... Oh, how can I sell it and make money? That's what it looks like all you've done. How you can use physics to improve your life. Okay. Yeah, that's all I see, fucker.
That I had a big misconception. I believed that every object...
So let's understand. He didn't have this misconception because he's been selling this wooey shit for his entire 15 years or whatever it is on YouTube. He's been selling this wooey shit. So he didn't have any view of a straight line. Look at that dotted straight line. That could be a photon if he gave it polarization. That could be a rational understanding of frequency. right, is the idea that there's a discrete bit and a discrete bit and a discrete bit. So you could understand, well, yeah, you could have a 10-mile wavelength at the speed of light, so a radio wave, and it would, it makes sense to have a bit and then, a bit of time and then another bit and then a bit of time and another bit. But it makes no sense to draw a 10-mile photon and say, look, this whole thing is a photon. No, that doesn't make any sense. So it's just bullshit that he would sit there and say his whole life he saw straight lines and he saw vectors and he saw, because he's been talking wave crap the whole time he's been on YouTube.
Object has one single trajectory through space, one single path.
So it just, I don't even know how he can say this with any kind of credibility. When he made all these, he made the silly double slit thing with the cardboard box, and then he did the silly one photon at a time experiment that was a complete pile of crap. He turned an experiment that he was going to do over a whole day into an experiment that took 5 minutes. Why? Because it wasn't working when he did it the way he was supposed to do it. Shit.
But in this video, I will prove to you that...
So he's not going to prove anything. This is just such goopy talk. All right, proving with these fake analogies and these false assumptions that this is how it works and this pattern works. This pattern is the same pattern. Waves don't do what photons do. They don't create double maximas. They don't create any pattern with a single slit. I mean, they fail in so many ways. The math isn't even the same because obviously the whole slit creates a wave. So two surfaces only create one wave. When in fact, as I demonstrated in the double slit experiment, it's clear there's 4 sources because there's 2 frickin' patterns. Will he account for the 2 patterns in the double slit? No, they just ignore the facts. It's disgusting. I mean, it's not that complicated an experiment, right? I mean, it's pretty simple. The outcome is really clear. You go on Google it, double slit, and you'll see lots of double slit patterns that have the 2 patterns. Where do they show you that? They don't. Simple truth.
This is not the case. Everything is actually exploring all possible...
So bullshit. I mean, he just said everything. Of course we are not. I mean, you walk to the store on the sidewalk. You're not exploring anything else. You're not going to Venus. You're not doing any of that horse shit. I mean, it's just amazing crap. How does he get away with saying everything? Oh, God, I already got to take a break and vomit. All right, continuing.
Possible paths all at once. So let's start with a simple thought experiment. Say you're...
So they're all going to be just thought experiments about wooey crap that can't happen anywhere in reality. Yeah, great.
You're at a beach when all of a sudden you see your friends struggling out in the water.
So this is Feynman's argument. So a lot of this is all just regurgitated Feynman. Okay, so this is the least action thing. The sand is hard to run through. You could even argue. So in some places the sand is harder to get any velocity going than the water. How fast you can swim. Some people can probably swim faster than they can run across the sand. So anyway, the whole thing gets convoluted. But it just has to do with there's 2 mediums you're going to go through, and the fact is the shortest path will be understanding getting the shortest distance over the slow path and the longest distance on the fastest path.
You want to go help him as quickly as possible, so which path should you take to get there? The shortest path is a straight line, so you could head directly towards him, but you can run faster than you can swim, and this path requires more swimming. So alternatively, you could run down the beach to minimize the distance through the water. But now the total distance is longer than it needs to be. So the optimal path, it turns out, is somewhere in between.
So this idea of an optimal path is fine, but understand that at the surface, it already tells you that. The surface decides how much deflection there's going to be. So when something hits a surface, how much it refracts is dependent on how dense the surface is and how slow it is for light to travel through that surface, in the sense of how many electrons, I would argue, the light has to go through. So the more electrons the light has to go through, the slower its progress, because it keeps pushing electrons which don't move the speed of light. Then it's going the speed of light as a force, then it pushes on the electron, it goes slower again. So that's why it's slowed down. So it just has to do with the number of electrons you have to go through, and the surface already knows that. The surface has got electrons on it jiggling, and they're jiggling based on their pressure. And their pressure is based on their proximity to each other. Okay, so the higher the pressure they're under, the harder, the firmer their jiggle. And the idea is the firmer it is, the faster the acceleration is, the more it's going to bend the light. The more the light will be bent on its first introduction to an electron, its first encounter with an electron. It's going to be either the light gets shot out that way or it gets shot in that way. That's the two choices.
To be precise, it depends on the speeds at which you can run and swim. Now, you might recognize this mathematical relationship because it is the exact same law that governs light passing from one medium into another.
So we know this law idea, this is just features, these are functions of mechanical systems. So again, if you did understand the surface has electrons bouncing up and down, up and down, up and down. They're getting pushed out of the surface and pushed back into the surface based on the attraction and repulsion of their protons, between the protons and the electrons. So if you understand that they can't really be going other directions, they're going to be going in and out. So there's really just two choices. The light gets reflected or it gets pushed into the surface. And obviously the force going in one direction, back, is going to probably be a different speed than the force going in the other direction, out.
So light also takes the fastest path from point A to point B. What's weird about this is that as humans, we can see where we want to go and then figure out the fastest route.
So again, they're implying that somehow there has to be a calculation done, and there's no calculation done. This route is the only possible route to get to point B. There is no other possible route. So just understand, the physics is saying you can't get to point B any other way than this. I can't do the straight line. It's not that its straight line is slower. I can't do it. It won't do it. Okay, the light will not go from point A to point B in a straight line. It also won't go all the way across the shore and then go back this way. It won't do that either. It can't do that. It's not possible for it to do that. All right, so this is the only possible path that gets to point B. So once you've assigned a place you want to get to, well, yes, there's only one route to that place, but there was never any choices. There's no decision that has to be made. The photon is going to decide. As soon as it hits the surface, it's going to decide where point B is. It's not going to be able to go to point B. You're going to have to tell it where point B is, you know, in a sense ahead of time, but there's no choices. The physics says this is the only way to get to point B. So once you understand it's the only way, then you can understand that, oh, okay, I get it. It doesn't have to do the math. The physical environment is dictating the circumstance. The mechanism is saying this is the only way to get to point B.
But light? I mean, how does light know how to travel to minimize its journey?
So you just understand how they're perverting something. They're taking a phenomenon and anthropomorphizing it and trying to say that somehow there was a decision made when there's no decision made to get to some other point. If I put some other point somewhere, I can't get there in a straight line either. I can't get there by going I have to go exactly one path. And that's the only path that'll get me to point C or point D or point E.
Time.
Now, here is where my misconception comes in. I shine a laser beam. The light just goes in one direction. I throw a ball. The ball just goes in one direction.
Oh, yeah. Well, this is a misconception. So let's just understand, it's a definite force. It goes off in space forever. Photons travel light years, okay, across space in dead straight lines, and yet we're supposed to believe that, oh, they have this huge radar system, and they actually went every possible way, and they went back in time, and they went forward in time, and this was what they decided to do. I mean, it's just such religious crap. No chance any of that shit is true.
You know, I would have answered, there is nothing strange about this. light sets off from point A in some direction. And
Right, and then the rules of the physical environment will decide what's going to happen to that light. It's going to hit the surface is doing something. The surface isn't dead, okay? They keep just drawing surfaces like they're dead. They don't have any features. There's nothing happening on the surface. No action on the surface. When of course there's a huge amount of action. It's fucking molecular crap in this universe, and every piece of molecular crap in this universe is hot as hell, actually. We are hot as fucking hell, right? Because we got a whole bunch of this going on. We're not cold matter.
then a little while later, it encounters a new medium. And due to local interactions with that medium...
So local interactions means the rules that govern the surface and the molecular structure. And for every surface, there's going to be a different angle that light will bend. So depending on how dense that surface is, that substance is going to decide how much that line got bent at that surface.
It changes direction, ending up at point B. If you later find that of all the possible paths, light...
So there's none of these are possible paths. So they're just pointing out, none of them will get you. None of them physically work. None of them anything can travel. It won't happen because you're disobeying the rule of the angle of refraction. So there's just no point in talking about all these other paths because all those other paths can't be traveled.
Took the shortest time to get from A to B, I wouldn't think it was optimizing for anything. I would just think that's what happens when light obeys local rules.
It's not some local rule, okay? It's a universal rule, okay? Refraction is a universal rule. It happens with every single surface, basically. It's to some extent, but obviously transparent mediums make it more obvious. But everything's doing it.
But now I will prove to you that light doesn't set...
So he said it again. You're not going to prove anything with anything called evidence. You're just going to talk a bunch of shit. So just like you didn't prove electricity doesn't travel through frickin' wires, you're not going to prove anything here. You're just going to talk a bunch of convoluted nonsense and convince a bunch of morons to believe in a bunch of wooey Holy Ghost crap. That's all that's going to take place.
Out in only one direction. Instead, it really does explore all possible paths.
So there's just, it doesn't frickin' happen. You can't make it happen. You can't force it to happen. There's no way to get the beam of light to do what you're claiming it's tested. It can't do it. It physically can't.
Paths. And the same is true for electrons and protons, all quantum particles. So the fact...
So more bullshit about whatever quantum particles are. So again, I revert to my simulation, okay? That's using a mechanical force to create exactly the function of electrons and protons. That is, the electrons repel each other, the protons repel each other, and the electrons and the protons are attracted. Not a complicated function where you really shouldn't think that you have to have special magic powers to sit there and create that simple mechanism.
That we see things on single, well-defined trajectories is, in a way, the most convincing illusion nature has...
So it's just such a bullshit. It is not an illusion. Bullets coming out of guns are not an illusion. None of this stuff is an illusion. It's just such bullshit. It's physics. They're obeying physical laws, and that's all they're doing. Physical rules set up by the functions that the objects have. Damn it. The force is moving the speed of light. The force interacts with the matter bits constantly. It constantly jiggles them about, and every time one of them jiggles, it's interacting with the force. So the force can't act on the force. If there's just force in the universe, nothing happens. The matter is what allows the force to take on a character, because now the matter doesn't behave exactly the same as the force.
Ever devised. And the way it works all comes down to a quantity known as the action.
a bullshit term. The whole thing, the action, like they've destroyed all vocabulary. So obviously, everything that moves, there's rules governing that movement, and I would argue that you can understand them that it has something to do with something quantum mechanical, in the sense that the movement is caused by discrete force. And the fact is that all you can do is transfer the force, as Newton said. As Descartes more exactly said, all you're doing is watching the force move from object to object to object to object. And if the force gets lost in all kinds of directions, well, it's very hard to make it do any work, okay? So if I have a school of fish and all the fish go in every direction, I'm not going to get much work out of those fish, am I? They're not going to get anything done. But if I can get all the fish to go in one direction, yeah, I can get them to, hit a shark and break its neck or something. some Aquaman task. What the hell? I don't know. I don't know why the image is... Oh, that's his own video. He's got his cartoon superimposed. He's blending the transition. Okay. It is an interesting blend.
In a previous video, we showed how an obscure scientist, Maupertuis, made an ad hoc proposal that there should be a quantity called action.
Right, so he did a whole video trying to set up this crap that, boy, this action thing is so important because guess what? They figured out. Electrons are doing the math. Photons are doing math. They're figuring out where to go. Blah, blah, blah. It's just such a pile of crap.
Which he defined as mass times velocity times distance. And he claimed...
So which is just another way of saying mv squared, right? Because you're just basically saying velocity times this distance, and depending on what units you have the distance in, you're just going to end up making the velocity bigger. In the sense you're just multiplying a velocity times a distance, which 5 miles an hour versus 5 miles, it's just 5 times 5 again. Mush. Silly mush.
That everything always follows the path that minimizes the action. Hamilton...
So again, more bullshit that everything does this. It's not everything. There's no evidence that everything obeys this efficiency rule. It's just... Obviously, a force has to interact on something. If it's interacting, then there's always a consequence that it didn't go somewhere else. So there's always, you could argue, some sort of obligation. It's like a pendulum swinging back and forth. There's a huge efficiency, right? The only thing that ruins it is the air resistance. And a little tiny bit of, you get rid of the air resistance and then get rid of a little tiny bit of friction and stress in the wire. If you can eliminate all of these things, you can end up having it swing for a very long time. There's no friction in the elemental universe. There's only forces. So there's no thing called a friction. There's no place to lose energy because it's really just interactions between electrons and protons and the field. And so it always is conserved. There's no weak kind of force. It doesn't matter, you can't get rid of it. It always is on the move.
Later showed that this action is equivalent to the integral over time of kinetic energy minus potential energy.
Yeah, so baby talk, right? I mean, frankly, it's just nonsense, okay? There's no such thing as mv squared. It's just stupid nonsense. Doesn't happen. It doesn't take 25 times the fuel to spin something 5 times as fast. I wish veritasium would make a video showing us it taking 25 times the fuel to spin something 5 times as fast. But no, he won't do that, okay, because they're not going to actually prove any of this stuff. So he says he's proving something. You don't demand to see that. To me, that's a pretty bold statement. I mean, saying that it's I can do the 100 times the fuel to go 10 times as fast. I mean, shouldn't you see that if they're going to claim that's the truth? Shouldn't they show you that truth? I mean, it's a pretty dramatic goddamn thing to say, isn't it? I mean, compared to what? Sasquatch theory? 100 times the fuel to go 10 times faster? Come on. Who believes that?
Action was useful and an alternative way of solving physics problems.
So again, all this silly crap of solving some problem that nobody considers a problem. So all they're saying is that they can create a system of very convoluted stuff going on, and they'll solve. And that's great, okay? I'm glad you have math, and I'm glad you can do that. All right, but don't pretend that the elemental math is saying what you're claiming it's saying. Let's see, how's the best way to say that? You can find a shortcut to do it. It doesn't mean your shortcut is a description of how it actually happens.
Especially when Newton's laws get too cumbersome.
So there's nothing cumbersome, okay, about Newton's laws, so that's just nonsense. So the laws are really simple, all right? And the fact is, though, yes, this complex pendulum, I put 3 legs on this thing, yeah, then it's almost like a 3-body problem. You have so many things that are holding energy, and you have to precisely understand how much energy each one has going in different directions at all times to predict its actual eventual location. So yes, it's a complex problem, but don't pretend that it's doing anything other than exactly conserving energy, conserving momentum, because that's what it's conserving. It's momentum, Newton's momentum.
But then, around the turn of the 20th century, action showed up at the heart of a scientific...
So this is bullshit, okay? It has nothing to do with this action principle, okay? The ultraviolet, the photoelectric effect is not an action theory, okay? In Einstein's own description, it's kind of clear that he's saying this is about discrete bits of clumps of stuff hitting a surface, okay? It's not about waves or ESP mechanisms.
Revolution, the birth of quantum mechanics.
So again, he talks about using Einstein to talk about the birth of quantum mechanics when Einstein rejected 99% of what you turned it into. The only part he accepted was the quantization of photonic energy. That's it. The rest of everything else you said about quantum mechanics, he said, prove it, show me. You didn't show him anything. I mean, they're going to talk about a bunch of spooky action and just ignore the fact that Einstein is famous for saying, I don't want a spooky action story. Now, Einstein's a hypocrite because, frankly, bent space is spooky action. So, I wouldn't, Einstein be a bad teacher too. Because he acquiesced. I mean, he talked about wave-particle duality. He made this statement. It sounded like he was reading it with a gun to his head. Well, you have to accept that there's a wave-particle duality because photons sometimes act like a wave and sometimes act like particles. But it's just that. It was just bullshit.
It all started with electric lighting in Germany.
So nothing all started. It's just amazing bullshit some more.
Think about what it's like in the 1890s, right? Electricity being more widely available, at least in urban centers, and things like, light bulbs.
Right, so they were trying to get more light out of light bulbs. So they would say, okay, how hot can we make something? How can we get more light out of it? And they kept just getting yellow light. All right, they're saying, why can't we get this light to go brighter and whiter? That was the real subject. And the simple truth is because ultraviolets is hard to produce. It takes a lot of energy to make a very tight frequency. So an electron has to move very fast to produce ultraviolet photons. And they just don't move that fast unless you do something extra. Eject them. You can't just heat them. You have to actually eject electrons to get enough momentum in the electron, enough speed for it to create the higher frequency radiation. I mean, it's really easy to understand that the atoms can't stay together if they have electrons moving that quickly. So there's a limit to how fast they're going to go in terms of just banging into each other.
They were new. They were literally the hot new thing.
Germany wanted to replace all their gas streetlights with electric light bulbs. So an important question was, how do you maximize the visible light given off by a hot filament? Scientists at a German research institute, the PTR, studied how much light different materials emitted as a function of temperature.
Yeah, and the truth was is that they all produce a ton of this infrared radiation that we can't use, that's of no value, and it's only a little tiny shred of this stuff called visible light that you get out of it. So the bulk of the energy is being wasted producing a bunch of infrared photons rather than visible photons.
At low temperatures, each material gave off its own characteristic spectrum, mostly in the infrared. But above about 500 degrees Celsius, all materials started to glow in the same way, with an almost identical distribution of light. The hotter the object...
Well, clearly there's not going to be identical because different substances will tend to produce different spectra, blah, 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 blah. All right, so these charts, you really got to understand what these charts are. The one going up is the volume of light of a frequency. So these are temperatures, not... The scale is for a temperature, and it's showing you, the bottom is telling you what the nanometer of the light is, and the top of the scale going up is telling you how many photons at that frequency. So yes, very few photons at this very low frequencies, not much radio wave. Okay, and then you got a ton of infrared, and then you really have to push the temperature before you're actually going to get into the visible range.
The more energy was emitted at every wavelength. And
so these are all wavelengths below. These are all infrared still. These, the huge 2,000 nanometers is, that's real infrared. I mean, that's way in the invisible spectrum.
The peak of the distribution shifted to the left.
But they still didn't understand how it worked theoretically.
So this douchebag is apparently that he produces this crap show. So I don't know what this, I don't know what the hell goes on here. Who's got this shit painting on the wall, right? This must be his house, obviously. Yeah, obviously. Look at this shit painting. Oh, God. Must be his wife did it or something.
So that was sort of the next step, right? Because if you can understand how it works.
So he's a producer. So it says Casper Medius, veritasium producer. What does that mean, veritasium producer? See, producer used to mean the guy who paid for it. So obviously this guy's not paying to produce this crap, I don't think. So what, is he the company that owns Veritasium or something? Come on, it's just, what does this even mean, producer? What the fuck does that mean?
Theoretically, then you can use that theory to potentially design new products.
They started by imagining the simplest object possible, one that would absorb all light that falls onto it and perfectly emit radiation based on its temperature.
So everything does that. So everything absorbs the temperature from the external world, incorporates it, and expels, nothing new there.
They came up with a hole in a metal cube. This hole is a perfect black body because any light that shines onto it will go straight in, bounce around inside, and eventually be absorbed. But
be eventually converted into signal inside the box. That is vibrations in the box. So the light will get trapped in the molecular structure, and all of that force energy will just be turned into little tiny jitters of electrons. So it will help jitter little electrons, but you won't have a photon anymore.
this also makes it a perfect emitter. Any radiation inside the cube can escape through the hole unimpeded.
So this is the electrons are moving. So the more you make the surface vibrate, the more it pushes on the field and makes the bits that will become a photon. One electron can't make a photon. It just makes one push, one compression in the field, and it takes other electrons to create the same compression.
Theorists reasoned that electrons in the walls of the cube...
See, a theorist did this, theorist did that. We all believed what they said, the end. And that's the whole subject, right? So we're stuck with the Bohr model, because everybody said, okay, we like Bohr for whatever reason, even though he's a religious kook. Basically said, quit telling God what to do. What scientist would say that to Einstein? Ugh.
Would wiggle around emitting electromagnetic waves. These waves would then bounce off the...
So there's no waves, there's just frequencies, okay? When you push, you compress, you tighten stuff, or you expand stuff. So if the electron's moving away, it causes an expansion in the field. If the electron's moving in, then it creates a compression. And all those expansions and compressions all start to oscillate. The whole box starts to oscillate. And the fact is like microwaves jiggling water. Okay, everything has a specific resonant, the best frequency. And if it oscillates at that frequency, the energy stays in the system because it's balanced.
Other walls. When you have two waves of the same frequency, where one travels to the right and the other to the left, they can interfere in such a way...
So this has nothing to do with anything. They got no evidence that inside the black body there's a bunch of areas that have a specific standing wave or any of that crap. No evidence whatsoever.
That they create places where there's no wave amplitude. Those are nodes.
So you could have that happen when you're using specific frequencies like microwaves. You shoot a bunch of narrow band of a bunch of frequency, and then you could end up having a resonant frequency. But if you got all the spectrum vibrating around, not likely.
And places where there's maximum wave amplitude, the antinodes. Waves like this are called standing waves because they don't really move left or right. And
so it's more nonsense about it's not moving left or right when of course it is, because if you were placed on it, the force itself is moving in a direction.
Inside a cavity, given enough time and reflections, it is only these standing waves that survive. All the other ones just cancel out.
I don't even know why this is in the video, because frankly, it doesn't have anything to do with anything.
So a sort of order emerges from the chaos.
Prove it.
In 2 dimensions, standing waves look something like this. For shorter wavelengths or higher frequencies, you can fit more and more different vibrational modes inside this cube.
Every structure, right? So if you put enough energy into it, every structure is in a sense going to behave like a trampoline or something, an elastic surface. So you put a bunch of energy on one side, it's going to cause vibrations that go through the material. Sound does the same. It's all the same thing. So yeah, you're just saying, well, if you put the energy in unevenly, you'll get an uneven distribution of these reflections. And so what?
So that in 3 dimensions, the total number of modes is proportional to frequency cubed, or 1 over lambda cubed.
Right, so you're just saying the higher the frequency, the more possibility to have wider and to create wider and wider, like every 8 nodes vibrations, every 25 nodes, every 500 nodes. So you can have a pattern that reoccurs every 500 instances of the main frequency, where it's building up and it keeps increasing its amplitude.
The expectation was there would be more and more waves inside the cube the shorter the wavelength.
This led directly to the...
Okay, so I get. So this is why they said that somehow they had the expectation that this would be infinite. That you could have an infinite frequency and you get an infinite something or other. And no, you can't. The universe isn't made out of that. The universe has the speed limited, the speed of light. It has a lot of things saying you can't do that.
Rayleigh-Jean's law. At longer wavelengths, it matched.
So let's just understand, it's useless mush, okay? It wasn't a law. It isn't describing physics that actually worked. It's just describing a relationship that doesn't work. It's not an infinite, it's not a parabola.
The experimental data pretty well. But at shorter wavelengths, the theory diverged from experiment. In fact, it predicted that...
So shorter wavelengths, higher frequency is the better terminology, right? So the higher the frequency, the more it gets way off, way off, way off. And we're not even out of the low microwaves here. Well, we're in medium to high infrared.
That at the shortest wavelengths, an infinite amount of energy would be emitted.
Yeah, just because their math doesn't take into account that there's a limited speed in the universe and the electrons can only move a certain speed and blah, blah, blah. So, yes, if you understand there's a speed limit, then you understand why you can't get that much energy into an electron or into its motion in the universe.
This, for obvious reasons, became known as the ultraviolet catastrophe.
I don't know why it would be called a catastrophe. They're not even showing the ultraviolet. They have an infrared catastrophe. They're making an infinite amount of infrared radiation.
The person to solve this problem was Max Planck.
But Planck
Okay, so this is solve is a kind of a tricky word. But to recognize that all Planck did was by, look, if you turn it into a discrete force, well, then it has a limitation. Then it's stuck in the physical universe, and you can understand that the speed of light is going to be a limitation. And so, yeah, you can understand it can't produce an infinite amount of energy.
almost didn't make it into studying physics. Because when he was 16 years old, he went up to his professor and asked...
Probably another way of looking at this is a resonant frequency, right? So you can bang on something, bang, 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 like on a bridge. And I can just keep banging on with my hammer. And I'll keep putting energy in, and it'll start vibrating the entire, lots of vibrations. But the fact is it's going to lose it all to friction eventually. Eventually, all that spread out energy is going to have so much contact with other atoms that it's going to start bleeding out into the earth, into all kinds of other places. And my tiny little bang bang is going to be less energy than what I'm bleeding out. So I can never knock the whole bridge down by putting more and more energy into the resident vibration. So the resident vibration has a limitation by friction, by the fact that it's going to leak the energy out. So it's another way of saying that, okay, at a certain vibrational speed, you're more likely to leak that energy out of the system.
him, well, maybe I could do a career in physics. To which his professor responded that he'd better find another field to do research in, because
Storytellers.
physics was essentially a complete science. There was just a few tiny little problems that they had to clean up. But besides that, it was over.
But Planck didn't.
Well, physics was kind of so much better back then in the sense when you have electrons, protons, and force. Yeah, and momentum. Yes. A really nice, complete theory, frankly. You want to see something's moving, you just look with, hey, what force affected it? What force caused it to move?
Listen. By 1897, he was a professor himself, and for the next 3 years, he struggled to find a theoretical explanation for blackbody radiation. He tried approach after...
So let's just understand, they're not trying to fix this stupid theory, they're just trying to explain why it peaks, and that's it. You don't get more out. And you can't get that, you can't get the others. The key point is the fact that you end up with this yellow light. You can't get the same amount of blue that you got red. It tails off, okay, kind of dramatically. And you're certainly not producing gamma rays and all kinds of other radiation. And so clearly heat isn't enough to give an electron enough velocity to cause that kind of radiation. And what does? Well, ejecting electrons. So if you eject electrons, you ionize, then you got ultraviolet radiation. And if you go a step further, right, and use an accelerator to create a potential difference across the electron, so you heat the surface, right, an electron gun, you heat it, cause the electrons to be willing to fly away because they already have some spring energy from the heat. So they're going to move a speed. And then you accelerate them further across a differential. Then you create radiation. gamma rays, X-rays, all of this other negative stuff. Then you have to start building cement walls around your experiment because it's a dangerous experiment. This is going to create electrons doing this really quickly, creating very compact frequencies. But it's all about the acceleration, right? So again, you have to free an electron. Just understand, an electron's sitting here bound. Okay, there's other electrons, and key to it is the proton. And to get it to go out, you have to move the electron faster than the proton force is saying stay. The pushing force. So it's like moving something quickly through gravity. If I have a gravitational body and I move something very fast, I don't get bent much at all, almost zero. So you can understand if I move something away from a proton very fast, there's not enough time for the pulling, quote unquote, the unpush to push the electron back. So if I can accelerate it quickly, it will be released. So ultraviolet, very compact frequency, gives an electron a quick acceleration, moves it quickly out of exposure to the proton. If you move it slowly with infrared, then it's going to be slowed down and pushed back because the gravity is going to affect it. The force is going to affect it. It's such a simple explanation. You don't need all this frickin' woo.
Approach, but no matter what he tried, nothing worked. He said, I was ready to sacrifice every one of my previous convictions about physical laws. Then, in a quote, act of desperation, he did something no one had thought to try. According to classical physics, the energy of an electromagnetic wave depends only on its amplitude.
So this is, whenever they use this word classical, it doesn't mean anything. So I don't think anybody thought that the amount of photons was the only thing that mattered. So I think people knew that gamma rays were damn dangerous. You didn't need a whole lot of them. You just need a few of them. I think they knew that ultraviolet light was going to cause ionization, which was going to be really different than any fucking infrared light. So it was never about amplitude. So it's just bullshit to call that classical physicist, as if classical physicists didn't know the difference between the higher capacity to break atom energy and the lesser capacity. And again, this is just like the gun and the recoil, the bullet and the recoiling gun. This isn't about more energy. There isn't more energy in an ultraviolet photon. It applies the energy more quickly, which means it accelerates whatever it hits more quickly, which means it escapes its environment quickly, which means there's less friction. There's not more energy, there's less binding force.
Not its wavelength or frequency. And it could take any arbitrary value. So any atom could emit any wavelength of light with an arbitrarily small amount of energy.
So nobody believed that. Okay, so even Feynman points that out. Come on. It's always been clumpy. It's just bullshit.
Planck tried restricting the energy so that it could only come in multiples of a smallest amount, a quantum. And he made the energy of one quantum directly proportional to its frequency, E equals hf, where...
Right, and it's not completely irrational to recognize the fact that from the electron's perspective, it's just a fact that the ultraviolet will cause an effect that's completely different than the infrared. But it's wrong to say it has more energy. It's just a fact that it has...
H is just a constant.
Consolidated that energy.
Think about what this...
And so the consolidation, this is harder to create. So in a sense, you pay a price to make a higher frequency photon. It's wrong for me to say you pay a price. It takes a more complicated environment to create a high frequency photon. So yes, they're more rare for that reason, but not because they take more energy or because they're made of more energy.
This does to the radiation coming from the black body. At a given temperature, the atoms in the cavity have a range of energies. Some have a little bit, a few have a lot, and most have their energy somewhere in between.
So, this isn't actually the reason. So I don't know whether I should go into a whole bunch of stuff about this. Isn't about the average energy. It is just about the peak energy. And the point is, until you're degrading the matter, that is turning it, ionizing it and starting to break it apart, you're not going to be able to create ultraviolet photons. So until you make something hot enough to break the bonds between the atoms, you're not going to have ultraviolet light.
For long wavelength, low frequency
I mean, there are other ways to create. I'm just saying, if you're going to do it through heat, you're going to have to you're going to have to break the substance into pieces before you're going to create your ultraviolet light. Now, there's other ways, using gases and other ways to create, using electricity to cause a higher proportion of the photons to be ultraviolet. But again, that's ionizing the gas. I mean, obviously you don't have to worry about breaking a gas, right? And obviously you do worry about breaking a solid object. So there's no way to break the gas. You can just ionize it, then deionize it, then ionize it, then deionize it. Alternating current.
Radiation, the energy hf of one quantum, is small. So all of the atoms have enough energy to emit this wavelength, and the spectrum matches the Rayleigh-Jeans prediction.
So it doesn't mean anything here because these charts don't even get into the visible range. So they haven't even gotten the nanometers to the point where you actually have the ultraviolet catastrophe. So they're not even showing that. They're showing the infrared catastrophe. I mean, he still has the nanometers at 2,000 nanometers. That is not visible light, okay? That's invisible light.
Very well. But at shorter wavelengths, higher frequencies, the energy of a quantum increases. And now, not all of the atoms have...
You have to get up to like 5,000 degrees. So he's got a chart that's got like 2,000 degrees on it. This isn't high enough temperature to start creating visible light. So his own chart is not even useful. I mean, if you're going to talk about the ultraviolet catastrophe, and you're not going to talk about the infrared catastrophe.
Enough energy to emit that wavelength. This is why experiment diverges from the classical prediction. The spectrum peaks. So
there's no classical prediction. There's no like, oh, everybody agreed that was the way to think about it. No, everybody thought so, and everybody. No, there's no such thing. So that's just bullshit. They just sell this crap like you believed it when you never even heard of it.
And then starts to fall, because fewer and fewer atoms have enough energy to emit one quantum of that radiation.
So again, it's the radiation is created by the motion of the electrons. The motion of the electrons decide whether the atom stays together. Because if the electron moves fast enough to create an ultraviolet compression, then it's going to be leaving the atom.
And there comes a point when none of the atoms have enough energy to emit one quantum. So
just jiggling a substance where you're not breaking the atoms isn't going to create enough speed in the electrons to eject them, and therefore they're not going to move fast enough pushing to compress the field energy into ultraviolet radiation.
Here, the spectrum must drop to zero. With this approach, Planck got a new formula for the radiation spectrum. Now, all that was left for him to do was to tune the parameter h, and when he did this just right, he got his formula to match up perfectly with experiment.
But he was sort of troubled by his own formula because...
So the h part is a constant, okay? So just understand again, so in the formula, if they changed what they measure the photon in from nanometers to some other unit, then they could change Planck's constant to 1 and get rid of it. So the constant only exists because they're measuring the distance, the frequency of a photon in the wrong unit. So if they changed the unit that they measured the quantity...
To him, it was just a mathematical trick. He had no...
All right. So if they change the what they measure the photon's wavelength, the number they're using for wavelength, then they could get rid of the Planck's constant.
No clue why it worked. It was purely formal. And most importantly, he had no clue what this H represented. I mean, he had introduced a new physical concept.
It fixes your units. You've picked the wrong unit for your frequency. So pick the right unit for your frequency, and then you don't need the H anymore. It's if they fixed, they could do the same thing with a gravitational constant. You get rid of the gravitational constant if you just changed meters or the mass, kilogram. Fix one of those, and then you won't need the constant anymore.
Without any reason.
He wrote, "A theoretical interpretation had to be found at any cost, no matter how high." So from that moment on, he dedicated himself to finding one. He later reflected that after some weeks of the most strenuous work of my life, light came into the darkness, and
so you can understand that if I push something in gravity, that I could perturbate its orbit. I could screw it up, but it would still be in orbit. And if there's a certain amount of momentum I could give it where I destroy the orbit. And that's really what this is about. It's about giving something enough velocity to escape the thing that's binding it. So the electrons are bound, and you're just really saying how much velocity. If I give them enough velocity to leave, okay, then I have to accelerate them quickly. Because if they stay connected to the force, it will drag them, okay, down. It will steal their energy. So it's like the tipping argument, in the sense that if something's tipping and it starts slowing down, and then you hit it again, you have to hit it with more energy. But if you hit it while it's still moving, okay, then you increase its velocity. So if you keep hitting it while it's still moving, you keep increasing its velocity, and you're going to get further, faster.
a new, undreamed of perspective opened up before me.
He introduces what we now call Planck's constant, and it has the units of action. Planck's constant.
Well, it says him, okay, it has the units of action. The whole point of it is to say that this energy comes in discrete bits. That's the Planck constant.
H is a quantum of...
A number of this decides. But again, the number is based on frequency, and the frequency is just really about the time. It's about how quickly you accelerate something, not about how much energy you use to accelerate it.
Of action.
Planck later proposed that anytime any change happened in nature, it would be some whole multiple of this quantum of action.
So it's kind of spooky, this breakthrough that starts the ball rolling toward...
So you could argue that the breakthrough is, let's say if you did have some kind of pendulum system, and you're just saying that basically there's one quantum, so you have a minimum amount of motion. And then you could add 2, and that would be the next level of motion. But you can't have something in between those two. You either go 1 speed, or you go 2 speeds, or you go 3 speeds, but you can't do some lesser amount. So you're just saying that anything that's wobbling or oscillating in space, if it's force that's causing the oscillation, then it can only collect it in units. 1/10 of the speed of light, 2/10 of the speed of light, 3/10 of the speed of light. That's all it's really arguing. And you could understand that even in orbitals, that the faster you make something go, the further out it has to orbit.
Quantum theory brings action in, not energy and not force, action. Gives you a hint.
So this guy's just saying that crap, okay? Not force. No, it is a force. It is basically a quantization of force as a unit. And then you're basically just saying, instead of measuring how many bits of force there are, You're saying how close are the bits of force. So Planck is using the wavelength, the distance between the bits of force, as the argument for the quantity that's relevant. And I'm not saying he's wrong to do that. I'm just saying that theoretically, though, it isn't more energy. There's still three little clumps coming very quickly will do more work on an electron because the electron will encounter less counter force. So there's less drag. So the quicker I can move the electron, the less force it has to overcome, is the simple argument. Just like if I can move through a gravitational field quickly, I'll have to do less work. But it needs to be understood that the quickness isn't more absolute quanta. It's just that you have compressed the quanta in time, and imposing energy more quickly causes effects with matter. Matter cares more about how quickly you expose it to energy than it cares about volume, you could argue. But it's not explicitly more quanta. 3 little bits, right? Separated by a distance, infrared, radiation. 3 little bits separated by a distance, ultraviolet. It's still the same 3 little bits. 3 little bits moving the speed of light. It's the same amount of gross energy. But obviously the ones that are going to hit a surface, bang, 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 are capable of accelerating electrons quickly, where the ones going bang, bang, bang aren't going to accelerate the electron quickly, so the electron's going to get dragged to a halt.
At first, the quantum of action got little attention.
Bang.
That is, until a 26-year-old patent clerk came on the scene.
So I don't, this isn't Einstein, okay? Well, Einstein's paper is like 3 paragraphs. Yeah, this action crap isn't in anywhere.
In 1905, Albert Einstein claimed that Planck's theory wasn't just a mathematical trick. It was telling us that light actually comes in discrete packets, or photons, each with an energy.
So he used the word light quanta, and you could understand what Einstein was saying in 2 different ways. So I wish he was more explicit, but I think he was just arguing that it is quanta at a frequency. It's bits at a frequency.
HF. Einstein used this insight to explain the photoelectric effect, how light can eject electrons from metal, but only when the frequency is high enough. If the frequency is too low, no electrons will be emitted.
For the very reasons that I've explained 1,600 times now, right? So the slow hitting means that the object has time to slow down, stop, and then you hit it again, it slows down, stop, and then you hit it again, it slows down, stop. Or worse, it starts heading back towards the proton, right? So clearly, if you hit it quickly, still moving, hit, still moving, hit, you're going to get something that was going 10 miles an hour to go 30 miles an hour. And it'll pass right through the friction, the drag of the force, binding it. It'll escape the binding force. They use the example of a well, and you're trying to knock something out of the well. You're trying to hit it and pop it out. But to me, the better argument is the tipping point argument. The fact is that you have to hit it quickly. You have to accelerate it quickly for it to escape the gravity.
Regardless of the intensity.
The idea of quantization spread.
So, right, and it should have been the idea of tipping points, okay, that electrons are in tension and they need to be accelerated over a very short period of time to escape their bound condition. They're in a bound condition, and the only way to escape it is to leave faster than the force can drag it back.
8 years later, Niels Bohr was trying to understand how an atom is stable if it has a positive charge in the center and...
All right, so it doesn't. Okay, in the case of a hydrogen atom, yes, it has a proton, but center starts to lose meaning. All right, so there's no idea that, okay, the electron is orbiting the proton. No reason to believe that, and certainly for the rest of the atoms, no reason to believe it. No good reason.
Negative electrons whizzing around it. Why don't they just spiral into the nucleus?
No, even more interesting is how could they possibly ever interact with each other without all of that momentum making them just bang the shit out of each other? How could the electron have this huge amount of momentum spinning around, okay, and then you're going to bind it with another object and there wouldn't be electrons smashing into each other, all kinds of changes in velocity, all kinds of bizarre movements? Now, the simple truth is there's just the electron attracted to the proton, and they're in a field of energy constantly converting, and they're wobbling in it. They're doing this, trying to wobble so little that they can get closer and closer to each other. So I could show my simulation again and just show how they can't just fly into each other because there is noise moving them this way, and as they move this way and this way, they don't see each other anymore. They see in very direct straight lines. They don't see with pupils or any of that crap. So for an electron to be attracted, it's all straight line force. So their alignment becomes critical to their capacity to function or to attract each other. So they're always going to end up in a field of other stuff, and they have to align themselves, orient themselves in that stuff, and they're going to be doing this kind of thing, seesawing. They're not going to be circulating, and they already know this because their own description of their orbital balloons are already describing kind of a teeter-totter thing. A wobble, not a circle. So, I mean, it was very bad to accept the Bohr model that electrons orbit. They're magnetic objects, okay? And you can place magnets and arrange magnets, and they'll balance each other's forces. It makes the whole idea of atoms sticking to each other make so much more sense to say they're literally sharing an electron in a location. One atom over here, this electron is attracted to the nucleus. This electron, the same electron, is attracted to another nucleus over here. It just makes sense that this electron isn't moving. Those are the bound electrons. They're not orbiting. It's so implausible. And again, especially if you do agree with me that force is a real thing. It's really in the environment. There's real elements of force hitting me from cell phones, from microwaves, from all kinds of things. They're hitting me. They're hitting my electrons. It's full of force. If you understand that, you can understand an electron can't be doing this, because that's the same as doing this. It would constantly be pushing on the force. It would be constantly being dragged to a halt. Electrons can't be shot any kind of distance because they're dragged to a halt. They can't plow through force. They have to be pushed by force.
Radiating their energy as they go.
And what he wants,
You have to create a field, a river of force to move an electron. That's what an electrical potential is. It's essentially a river of force. And you're just saying, I'm going to throw the electron in and have it pushed by the river of force. All right, well, there's a point where I have to say, I've got to break this into a couple of parts, I guess. So I will choose to do that now, I suppose. Yeah. And yeah, there's just, this video is just so bad. All right, well, anyway, so this is just going through the old physics, and then he's going to really push this idiotic notion that somehow it's all this wooey, wavy, mushy idea that somehow electrons have all kinds of knowledge properties. You know, they're little battleships, they got radar, guns, this, that, you know, all these fancy features. And somehow none of that has been created into anything in this universe we live in, the big universe. Somehow none of this ESP power, can we channel into. It's just so bad. So anyway, I mean, believe whatever. I mean, I can't. I'm just saying, you're just humans are really stupid dupes. You're just such goddamn dupes. I mean, you fell for the religion thing, and you're clearly going to fall for a new religion. You're just prone to believing in absolute crap, and belligerent to the idea that, there might be a simple answer that doesn't involve a bunch of wooey fun features. It's just... anyway. All I can say is, fuck you. You all deserve it. Fuck you, you idiots. Go ahead. Be a fuck you moron.